Hello everyone, my name is Alanur Heper. I'm 16 years old and I've been a part of the IB Diploma program in TEDxYouth BursaKoleji. I've recently taken the TEDxYouth BC exams and I'm a student who is specifically interested in the areas of chemistry and engineering. And I recently had the chance to do an experiment, carry out an experiment and a research paper that was about the laser ablation method that is an alternative process to produce nanoparticles, to synthesize nanoparticles in liquid. And today I'm going to share my experiences and the knowledge I have gained from this research paper. So I want to start by quoting the words of Richard Feynman, who has been an important scientist and important physicist of our age. He's specifically known for his work on quantum electrodynamics, and he had great contributions to nanotechnology. So he gave a speech in 1959, which was called "There's Plenty of Room at the Bottom," which I wanted to quote here, because here he gave an intuition to the scientists and the world and students like us about what nanotechnology meant and what could be the improvements in nanotechnology and nanoscience. So I found this quote very inspirational and I wanted to add it to my presentation. He also repeated his lecture in 1984 in Caltech, and there he gave I think a very interesting example, which was he said we could fit the entire scientific library of Caltech onto a library card using the means of nanotechnology and working on nanoscale. And he also mentioned tiny machines that could be working on nanoscale, which I found pretty interesting and fascinating. So I want to move on by talking about what nanoparticles are. So simply, nanoparticles are extremely small particles that have at least one dimension in the range of 1 to 100 nanometers. And since they are extremely small, invisible to the human eye, they have very unique properties that we can manipulate in order to benefit them efficiently. So I want to give us an example to understand how small nanoscale is. When we think about the DNA that is found in the nucleus of human cells, the diameter of one DNA strand of a DNA is 2.5 nanometers, which means the nanoscale is extremely small that can even fit into our cells, into the nucleus of our cells. So I can move on, I think, with the properties that we're using nowadays about nanoparticles and which applications we have already met, probably. So nanoparticles are applicable to both industrial fields, medicational fields. For instance, the scratch-proof eyeglasses that we see or the crack-resistant paints that we are using today are the product of nanotechnology. And specifically today, I want to focus on the use of nanoparticles for medicational applications, like drug deliveries, gene therapies, or the antibacterial properties of nanoparticles, which can be applied to wound dressings, hydrogels, and which can be very beneficial to enhance the process of healing of these wounds. So now I'm already going to mention how these nanoparticles are effective, how can they exhibit antibacterial properties in my next slide. So yes, my question here was how can the nanoparticles, particles that are just extremely small, can exhibit antibacterial effects against these bacteria. First, before I mention it, I wanna mention something. Today we're using antibiotics in order for their antibacterial properties. We all use it when we caught a disease or anything. However, especially due to the excessive consumption of antibiotics, we can see that there has been bacterial strains that are extremely resistant to many antibiotics, which is a risk for the future of how we combat with these diseases. So I think nanoparticles can be a futuristic approach to for us to benefit from their antibacterial properties. So how can they exhibit these antibacterial properties? There are four. Honestly, this topic hasn't been fully explained or discussed by scientists. However, there are four approaches that they are working on. The first one is the disruption of this bacterial cell membrane, which will damage the biological functions of a bacteria. And I think this one is pretty close to the third one, which means the penetration of the bacterial cell membrane. And the second one is the generation of reactive oxidative species. So what are these? If they are produced inside the bacterial cell, they can disrupt the morphological and physiological properties of bacteria, which may lead to the death of these bacteria. And the fourth one is induction of intracellular antibacterial effects. And all of those four mechanisms lead to the inhibition of bacteria or the killing of bacteria by nanoparticles. And since nanoparticles exhibit multiple simultaneous mechanisms against bacteria, they are harder for bacteria to be resistant against. Because to be resistant, bacteria has to go over mutations, which is harder in this particular case. Especially, I could give silver nanoparticles or zinc oxide nanoparticles that are effective against bacteria strains as E. coli. And I would like to continue with how, okay, these nanoparticles are really beneficial, especially in medication applications and industrial fields, but how we can produce them is my question in this presentation. First of all, when we think of how to synthesize nanoparticles, there are two main approaches that scientists are following. The first one is top-to-down approach, which simply means producing nanoparticles from a bulk material from a greater piece of metal or greater piece of material into smaller materials. Whereas the bottom-to-up approach means producing nanoparticles from even smaller particles. In both ways, we're producing nanoparticles, but our approach is different. And the first one, top-to-down approach, the laser ablation method that I'm going to mention in my next slides is going to be an example of the top-to-down approach, whereas the chemical reduction methods that are mainly used in our world today, it's an often preferred method, and that is an example to bottom-to-up approach. And it works with chemical reduction, where we have a silver precursor and an additional agents, which has a great consumption of chemicals. So when I was preparing my research paper, I had the idea of minimizing the usage of chemicals in my research paper. So that's why I didn't prefer the method of chemical reduction, but rather chosen laser ablation as my method to synthesize nanoparticles. So I would like to continue with, this gives, I think, a great picture of what I just mentioned: physical methods, chemical methods, top-to-down approach, and bottom-to-up approach. I think we can continue. Yes, the laser ablation method is the alternative method that I suggested that we could use more oftenly in our today. So I'm going to mention the mechanism of pulse laser ablation in liquid method and what are the parameters that are effective when we're using this method. So yes, as I mentioned, I prefer this to minimize the chemical consumption, and also I wanted to mention the mechanism of pulse laser ablation in liquid. First of all, to carry out the pulse laser ablation in liquid, you need three main things. You need one target material, you need a solvent, and you need a laser. This laser has to be pulsed, as you require high peaks of instantaneous energy, which means it can't be a continuous laser, but rather it should be a pulse laser. So when you have your pulse laser, if you have your solvent, it can be distilled water, it can be isopropyl alcohol, it can be the organic solvents like this. And if you have your target material, you can ablate nanoparticles from the surface of the material, which I think is pretty interesting at this point. And how the mechanism works is simply when you're ablating the material, the laser actually, when the laser gets in touch with the surface of the material, a plasma is formed on the surface, which carries nanoparticles inside. And these nanoparticles are quenched and cooled rapidly by the water, which results in the spread of nanoparticles inside liquid medium. And with this method, we can produce these nanoparticles inside the liquid medium, which I think is pretty interesting. And of course, there are lots of parameters, especially related with the laser. For instance, the laser power, pulse scanning speed, or pulse repetition rate. Actually, there are like numerous parameters that you can change to enhance the amount of nanoparticles that you're producing inside the liquid. However, these were the ones that I have chosen, and laser power and pulse repetition rate were pretty effective in my example. And here I have a video that I have taken when I was conducting my own research paper on how this laser ablation, laser etching process was working inside the liquid. So I think, can you imagine? This is, we can't hear the voice, but this is how the process works. There I have the laser, and I have the target material inside my solvent, where I'm conducting the etching process. So this is a 15-second video, but at the full length of the video, when it took like 4 minutes, at the end you can clearly see the color change, because as the nanoparticles are being synthesized inside the liquid medium, a physical phenomenon that is called plasmon resonance causes the liquid to change its color. Especially for nanosilver that I was working with, the yellowish-brownish color is very often to observe. Or, for example, in golden nanoparticles, you can see a more ruby red or purplish color. And I want to show a picture here of my vials where I synthesize these nanoparticles. And the first one you can see, in the first vial you can see distilled water. And in the second, third, and the fourth vials, there are the samples that I have synthesized nanosilver. And especially in the second and the fourth one, you can see a color change. It was just the distilled water and silver nanoparticles, and you can see its color as a more yellowish color, which is, as I mentioned, caused by the plasmon resonance that occurs depending on the size of nanoparticles. You can see on the fourth vial, I have a 33% tea extract inside the vial, and on the fifth, sixth, and seventh vials, I have tried to synthesize the nanoparticles, which cause the vial to change its color. So why did I add 33% tea extract? Because in my research paper, I was investigating the effect of whether we could use tea in order to in order to immobilize the particles that are being synthesized inside the liquid medium. Which means when you produce these nanoparticles inside the liquid medium, you can cause them also to agglomerate, which is something that is undesirable, especially when you're working in wound dressing applications. So when I was working with this, I decided to use tea extract as a capping agent that would prevent the silver nanoparticles from agglomeration. And this was what my research paper has turned out to be. Here, at the end, after I synthesized these nanoparticles inside the liquid medium, I used a wound dressing recipe that I aimed for it to be a wound dressing material on the future. And this was what is known as hydrogels. And the final result was like this. And I want to thank you all for listening to me. Here I have a video if you're interested in the field of laser ablation or nanoparticle synthesis. This video is has been a pretty beneficial video for me to understand the concept in general. And I think if you're interested, you can watch this video, or if you have any questions, you can email me whenever you want. I want to thank you so much for your attention and for your time. That's all from me.